Gentlemen, I shall be talking to you about a relatively very important aspect of civil engineering, but unfortunately a relatively less and underemphasized topic, and that is design considerations as related to preventive maintenance of masonry structures. Gentlemen, we all know that Slocum constructed Bhakra Dam, but very few of you would know that he had no formal education. If Slocum can construct a massive structure like the Bhakra Dam without any formal education, what do you think is civil engineering? In my humble opinion, it is simple, plain common sense. Kindly remember this. We shall come back to this aspect toward the end of the talk. I shall cover my talk in the following phases: the structural design, common aspects, masonry structures in phase 1, and in the phase 2 we shall talk about RCC structures. Now, gentlemen, in my talk I shall be talking to you about certain things which are overlooked by a designer, and that is why we land up into problems. We shall not be covering those aspects where a structural designer makes a mistake, because when a structural designer makes a mistake, his mistakes can be disastrous. So, we are talking about simple things which are ignored by the structural designer while designing a structure. So, gentlemen, design is not a mundane mathematical process, it is an art. Just like an artist, he conceives the structure is subject, he understands what he wants to depict, makes the picture in his mind, and then goes about his creation, whether it is a sculpture, a painting, a novel, or anything else for that matter. Similarly, a structural designer, if he has to do justice to his work, he has to first conceive the structure in his mind, understand and start behaving and start understanding how it is supposed to behave, and then go about the design process. So, the ingredients of design, gentlemen, would cover the service requirements, whether the structure is supposed to be a hospital building, a school building, an aircraft hangar, a storage accommodation, residential building, and what all you have. Then you have the configuration. Based on the service requirement as to what the building is supposed to be, then you got to have the configuration, whether it is going to be a framed structure, whether it is going to be a load bearing structure, or any other type of a shell structure, depending upon the service and other requirement that is supposed to meet. Then you have the response as to under the load and service conditions, how do you expect the behavior of the structure. So, you must know the response of the structure as to what to expect out of it. Then you have the conceptualization. After you have gone through the whole exercise, you conceive a structure in your mind, keeping all these broad parameters in your mind. And then finally, you have an interface with the architect. Gentlemen, unfortunately, the architect makes a plan, passes on to the structural designer takes the calculation, makes the drawings, and passes them back to the architect. This is not the real method, gentlemen. The real method is a very close interaction. The architect and the structural designer must act as a team, closed in a team, so that we have a properly behaving structure which has a proper response and good looks and aesthetics, and serves the purpose for it is meant for. Then, as a designer, gentlemen, the most important thing is we must first be able to draw the deflected shape of the structure under a given load condition or a combination. This is very important, gentlemen. Today, in the era of computer design, you put in the inputs into the computer, you get a printout. You have some negative moments, you have some positive moments, but you got to understand where those moments and your shear forces are going to act. Unless you understand that, very simple thing, you have got to understand as to how the shape of the structure will be under the deflected conditions, under the load conditions, and only then you will be able to place your reinforcement at the correct places and design the structures, cross sections and other things correctly. So, you got to understand that, and then only interpret the results that you got in your hand. So, the common aspects as related to all types of structures are the soil investigation. This is one simple very important consideration, gentlemen. Most of all you come across people saying, I have made this building over here, this has got a bearing capacity of 9 ton per square meter, where is the necessity of carrying out another soil investigation for the adjacent building? It is wrong, gentlemen. Soil, below the soil you do not know what is there. It may be a filled up earth, it may have been a pond sometime earlier. So, the IS and other codes, they laid down as to what is the requirement and at what spaces and what intervals you got to have the bearing capacity test done. Please do it, particularly for a high rise or an important structure like an elevated water tank, and for that matter anything subjected to strong winds and seismic considerations. Then the joints, the location of those joints and how they are going to be sealed. This is something very, very important, gentlemen. We just provide arbitrarily at any place put a joint without considering as to how is it going to be related to the response of the structure under wind and the seismic considerations. Similarly, we forget as to how are we going to seal it against the weather conditions, against water conditions. Very beautiful structures are made, but those joints, they continue to leak just because you have not paid adequate attention to where the joints are going to be located. Then unambiguous detailing. Gentlemen, drawings are the language of the engineer. The person who has made the drawings obviously knows what he wants, but the drawing is a drawing if it is understood by the other person. The person is going to read it, execute it and translate it on the ground, whether he understands what you are trying to say. So, proper detailing is very, very important, gentlemen. Compatibility of the materials. The materials, when they are going to be put together, used in combination with each other, we must have compatibility, their modulus of elasticity, their thermal response, their other responses under behavior or load. You cannot put anything with anything else and then expect the structure to have no problems later on. So, you got to ensure the compatibility of the material that you are using for construction. Then you got to guard against false economies. Sometimes they say we can make the things very narrow. Olden structures, they used to be very massive structures, but we hardly had any problems. Yes, but today the modern day construction, we are trying to squeeze, make them smaller and smaller and smaller without realizing as to what are the effects on the structure. Yes, you must economize, but you must be careful about false economies. Now, some of the common pitfall areas, the basic aspects, the slenderness ratios. Gentlemen, this is the least understood aspect as far as masonry structure design is concerned. I shall come to it. The openings and then the design of the wall thickness. We just make a masonry structure and put a roof on top of it. 1 brick wall, 1.5 brick wall, we just go by the thumb rule. I shall come and give you some examples on this as to how it affects the bearing stresses at the various places as related to the span of the beam or the lintel. Now, slenderness ratio, gentlemen, for walls, the effective height divided by the effective thickness or the effective length divided by the effective thickness, whichever is less. For columns, effective height divided by the corresponding lateral dimension, thickness or the width as applicable. This is a simple definition. Now, gentlemen, this is a sketch I have taken from one of the IS special publications. Now, you just imagine for various conditions, if this is the wall thickness and this is the effective length. If you got an opening inside and that opening, this is less than h by 6, the effective length becomes 0.8 L2. Now, imagine the difference between the two slenderness ratios, and in the case of the free end without adequate lateral support, the effective length is 1.5 times L3. Now, this is hardly ever taken by any designer into consideration, something very important, and when a building develops cracks, you say somebody has gone wrong somewhere, but you have failed to understand. This is just for an idea that I have tried to give you. There are nomograms given in the building codes, you got to keep that into mind. Now, this is the nomogram from the same handbook. Just for the purpose of understanding, for a class 200 loading at 2.8 meter story height, we have the basic stress on this ordinate. This is dependent upon the strength of the bricks and the strength of the mortar used. So, based on that you come to the basic stress. Then say for example, the basic stress is 9.5. For a 2-storied building, you come to the reference line at point A, come to the span point, come to the reference line 2, and then you go up passing through the percentage openings, no openings to 50% openings. And as you will see, for a span of 3 meters, you require nearly 1 brick thick wall. For 3.6 meter span, you require 1.5 brick wall, and for 4.2 meter span, you require 2 brick walls. Now, just imagine, have we ever considered this kind of a thing? Very simple, but you normally do not ever ignore it, and if something goes wrong, then we say the building has developed cracks. Now, this is a very common occurrence, gentlemen. You see go across any other building, you will find the bearing stresses have exceeded and you have cracks. There is such a small little lintel. Now, this explains the bearing stresses not having been considered and the opening size not having been considered for the wall design. Now, to look after these aspects, gentlemen, there are two simple books which have been published by the Bureau of Indian Standards. The first is the Handbook on Masonry Design and Construction, SP 20, and the second one, Handbook on Causes and Prevention of Cracks in Buildings, SP 25. Both are Bureau of Indian Standards publications. Must go through them. They are simple, basic, elementary things, and once you gone through these things, I can assure you, gentlemen, most of the problems will be looked after. And with this, we come to the end of part 1 of the talk.